We have already learned that matter is anything that has mass and occupies space. Matter exists in three physical states, namely solid, liquid, and gas. A substance can exist in any of the three states depending on the prevailing temperature. To learn the effects of heat on matter, we shall observe a few experiments. Experiment: Effects of heat on naphthalene. Let us observe this experiment to learn the effects of heat on naphthalene. Naphthalene is a white crystalline substance with a strong odor. In this experiment, naphthalene is placed in a boiling tube and its temperature is noted. The boiling tube is placed in a beaker and heated. The temperature is recorded every 30 seconds until all the solid has melted. The heating continues for about 2 minutes. The observations show that when naphthalene is heated, its temperature rises steadily until it starts to melt. At this point, the temperature remains constant until all the naphthalene has melted, then the temperature starts rising again. Heating in a water bath does not allow the boiling point of naphthalene, which is 218 degrees Celsius, to be attained, and therefore protects the thermometer from breaking. This graph represents the temperature against time obtained when naphthalene is heated to melting point. Such a graph is called a heating curve. If liquid naphthalene is allowed to cool, the reverse can be obtained. It is then referred to as the cooling curve. At region AB, the temperature increases steadily as naphthalene absorbs heat energy. The heat absorbed increases the kinetic energy of the particles and they vibrate more vigorously. At region BC, the temperature remains constant until all the naphthalene melts. Here, the heat supplied is used to weaken the forces of attraction holding the particles of naphthalene together. The particles, therefore, move far apart. As a result, the naphthalene changes its state from solid to liquid. At region CD, temperature rises steadily as the liquid naphthalene absorbs heat energy. The heat supplied increases further the kinetic energy of the particles, causing them to move fast. Experiment: What happens when water is heated? Let's observe this experiment on the effect of heat on water. In this experiment, distilled water is placed in a boiling tube as shown, and its temperature is noted. The glass tubing ensures that there is no pressure buildup in the boiling tube. Increased pressure causes an increase in the boiling point of water. The water is heated gently and the temperature is recorded every 30 seconds until it boils. When water is heated, its temperature steadily increases as molecules absorb heat energy, which increases their kinetic energy. The temperature of the water continues to rise until the water starts to boil. The temperature of the water remains constant as it boils. This is because the heat energy supplied is used to break the forces of attraction holding the particles together. As a result, some particles break free and the water changes from liquid to gaseous state. The graph of temperature against time obtained when water is heated to boiling is given in as shown. Change of state from solid to liquid and liquid to gas can be reversed by cooling. On cooling, the gas condenses into liquid and finally, the liquid freezes into solid. The use of a thermometer enables us to observe that changes in the state of matter are not accompanied by temperature changes. Some forces of attraction hold together the particles which make up matter. Heating provides the energy required to overcome these forces. Some substances such as iodine do not undergo the above changes because they sublime. The explanation for the behavior of matter in terms of the movement of particles is provided by the kinetic theory of matter. Thank you for watching this chemistry lesson. Please subscribe to this channel and other Genius channels relevant to your level of study.